Okay, thank you very much. And at first, thank you to join today's training. And today is the last day of the training, and we nearly take more than 21 hours together. And today, the last 3 hours, we will still discuss something about the wireless technology. And yesterday we talked two topics. One for the Fit AP and the key configuration of the AC, right? If you deploy the Fit AP and AC together in your network, we have to let the Fit AP get an IP address and then to discover the AC and join the AC and get the configuration and also upgrade the version from the AC. So this is a detail we discussed of the yesterday's first topic. And then AP and AC will establish the cap web tunnel. We have two tunnels, one for the data tunnel and another one for the control tunnel. In the control tunnel, we can get the configuration and also can get the upgrade version from the AC. And later, if we want to forward the message from the terminal, if we use the mode is centralized mode, we will forward the traffic to the AC, use the data channel. And then if we establish the mode is a local forwarding mode, after the AP online successfully, the AP can direct it to the best path and then forward the message to the destination. And this is the first part of the Fit AP. And the second part, in the network, if the places is very big and about the signal, it will be reduced when we go around, when we movement, and the signal will be reduced and far away from the AP. So in this scenario, maybe we will deploy multiple AP in our network, and we have to do the function of roaming. We want the terminal, the station is working, but the service is not disappear. We also can use use the original IP address and use the original VLAN, but still we can visit the internet. So we talk something about the roaming, and about the roaming, it's a little complex because we have to establish several tunnel between the AP or maybe between AP and AC, also inter AC. If the AP located in different ACs, we have to establish the tunnel between the AC and then to force the traffic out. And pay attention some scenario, for example, in the stadium scenario, and the places is very big, but all of the AP provide the service for the same IP address for the same VLAN. In this scenario, we have to disable the roaming. Otherwise, all the traffic will be forwarded to the home AP, and the home AP have to forward the traffic out. So the performance is very high requirement for the AP. So in this scenario, we have to disable the roaming function. So this is two parts yesterday. And today we still will talk about three parts. If we deploy the AP successfully, we have to do one function we call is optimization. We have to make the signal better for us to improve the experience for the terminal, for the station. And the second one, if in our network you deploy the AC to manage the APs, if only have one AC and this AC or the link is broken, the network is broken. All the terminals connect with the AP cannot forward the message out. So in this scenario, we also need one technology to improve the reliability. So with the second topic, we will discuss something about the redundancy. And this redundancy is only used for the AC. And of course, about the wired network, you also have to keep the network to provide higher availability, like to use STP, to use link aggregation, to use VSU. But the detail part we already discussed last week. And the last one, we also will talk something about the site survey. When we deploy the real devices on the customer on the customer places, we will do the site survey at first. We have to test which places to deploy the AP is better and how many APs we have to deploy. Because maybe the signal coverage is good, but we also have the limitation of the number capability. So what's the detail we have to know before we deploy the real devices on the customer site? So this part we will discuss 3 topics today, and the last we will have a brief summary of the whole technology, maybe around 30 minutes, and to discuss the technology from the first part to the last part, why we choose this topic on this training. Because this is the first day when we explain the arrangement of the training, why we choose this technology. So now let's begin the first topic of the optimization. This one is very important because the training is used to discuss every accept and relevant concern requirement of wireless network optimization. Because if you deploy the AP or maybe deploy the AC in your network and you give all the configuration of the devices, the difference between the wireless network and the wired network is if you deploy the technology on the wired network, all the devices like the switch, like the router, like the maybe computer, all of them can forward normally because we use a physical cable to connect with each other, and all the devices were located in the same places. But the difference for the wireless is because maybe in your network you also have the other interruption like some special devices like the microwave and something like this. So another reason is we will use a wireless cable to connect with each other, and the door, the wall, like the water, like the human body, we have a different influence for the network. That's why after we deploy the network successfully, we also have to do one important step is to do the optimization to make the network better to improve the experience for the customer. And about this part, we have to know the first one is what is excellent Wi-Fi experience for the customer. Because maybe now we are engineer, but we also is a customer in the real network. For example, when we go outside for maybe for dinner, for lunch, or maybe we go some garden places to have some activity. And I think everyone will use the phone. The first thing is to connect to the Wi-Fi and then to visit some resources. So we also will have a judgment from the user how to define the excellent Wi-Fi experience. We will have lots of parameters. The first one, maybe we hope that the signal is full. Someone maybe say, I go around and far away with the AP, I cannot get the signal, so I cannot connect to the network and to reach the resources. So we hope we can have a full signal. And the second one, we hope if the Wi-Fi have some authentication. For example, you click to the government Wi-Fi, and then they will ask you to do the authentication. We hope the authentication is faster, no need to enter every parameter step by step. Maybe use the phone directly click and then you can visit the internet. So we hope this process also can be faster. And another one, we can provide the smooth internet surfing. When we go around, maybe all the metric can be all the resources we can visit, although maybe on the car, although maybe on work. And another one, this is seamless roaming. This is a main four requirements we want to use in the network. Has a full signal and the faster authentication, smooth internet surfing. We can get some higher speed, and we also can provide the seamless roaming. Although maybe we are on the road, but the resources we can visit all the time. Also, maybe you can lose some packets, but I think it's not matter for me. And no need to log in again and to do the authentication again. So there are 4 main requirements for us. And how to do the optimization, we also have some tools. Wi-Fi experience is bad, and then we have a tool. This tool we call it WIS, W-I-S. This is the tool of the Ruijie company. And on this platform, this is a platform that then we can manage the devices, and then we can do some configuration to deploy some service. And the key point of the platform is we can do the optimization on the platform. And maybe you only need to one click, then all the devices can do the optimization automatically. And in some basic scenario, maybe click the WIS platform is enough for us. Of course, in some complex, we'll still have to do the optimization one by one to get the best result. And about this WIS, this platform also will also is a new topic. Maybe you can maybe in the future we can discuss it, or maybe you can contact with your post sale to get some information of the WIS. And after we do the optimization, maybe by the WIS, maybe we do the optimization manually, and finally we can get the good experience. So this is the tool we can use. And later we also will explain some main principles and some parameters, how to judge the optimization and to get the better signal. And how to do the optimization, we have several principles. The first one also is the simplest one. We can optimize the channel. Because about the principle, we have two IF interface. One is 2.4 gigabit radio and another one for 5 gigabit. This is the first day we discuss the basic principle of the 2.4 gigabit and 5. And about 2.4 gigabit, here totally 13 channels we can use. Even in some special country, we have 14. And we recommended to use the channel of 1611 because these 3 channels is not overlap. So you can use these 3 channels in different APs at the same time. This is the best solution. If you use if your AP only supports 2.4 gigabit, and in some 5G, yes, with 20 MHz, yes. And if in some high density like the studio scenario, if you deploy the 2.4 gigabit, you can use 1, 5, 9, and 13 at the same time. But pay attention, if you use this channel, maybe we have to change some parameters because about this channel, they have a little overlap brand. So you have to change some parameters to reduce the bandwidth is shorter. Okay, so this is a 2.5 gigabit. And about the 5G radio, and we can recommend it to use 13 non-overlapping channel like these channels. And about this 13 non-overlapping, when we choose to deploy 5 gigabit, we also have another suggestion. And the first part, this one, this part and the rest part, this 2 part is divided for 5.1 gigabit and another one for the 5.8 gigabit. So if you have 2 radios of 5G, and then we suggest to use 5.1, 5.8. Okay, 5.5 channel. No, about the 5G, we only use 5.1 and 5.8 about the normal radio AP devices. And we also suggest to use 194. That means this one channel and then use this channel. And then we will suggest to use this channel and to use this channel together. And that means 5.1, 5.8, and 1 by 1, because maybe some terminals only support 5.1 brand, or maybe someone only support 5.8 brand. So we suggest to use 5G 1 by 1. And another one is why we don't use 149 and 153 at the same time, because on the 5G we can use some bonding technology to make the 20 mHz to become 40. So in this scenario, we suggest to use this channel at the same time, and we can reserve this channel. Maybe in the future you need higher speed and you can use bonding technology. So this is a 5G. And AP deployment planning and the layout should suggest to use honeypot to minimize cross-channel interference and create high-density Wi-Fi usage. So this is a suggestion. For example, if you use 2.4G, you can use 1.5 and 1.5.9 13 at the same time. And this is a location suggestions. And then one honeycomb shape, you can make them as a whole part and then to connect with each other. Finally, if in the high density scenario, you can make the topology like this part. Of course, this is the suggestion for the scenario that we have lots of people, or maybe your places is very big. And also you can get get a result like this one. You use the AP and to record, for example, about this AP, 2.4 gigabit, we use the channel is 5. And if you have two radios and another channel, we use this one, 157. And this is the application of AP, but we use 13 and 165. And another one like this. So finally, we can remember to choose different channel for different APs to avoid the influence as much as possible. And another for the channel optimization, the first one, we suggest to use the WASE platform to optimize the development, and which can solve most of problems. But if the experience is still not good, we need to optimize manually. Pay attention about this part. We can solve lots of problems. That means not all the problem can be solved. So finally, maybe we still have to optimize manually. And then a few terminals maybe do not support certain channel in the 2.4G. So pay attention about this part. This is a limitation of your terminal. Maybe you deploy one AP and choose the channel is 13, but your terminal cannot search it. Finally, you will find use your phone to test the result, but you cannot see the SSID. So this one also maybe is a reason. And how to solve this reason? Maybe you can upgrade the network card driver, and then you can find the certain channel. And at present, 5G can be planned with certain non-overlap channels, and the channel resources are abundant. So that's why in some scenario, we say if the devices can support 5G, we will choose 5G at first, because there is more channel resources. And we recommended to use 20 bandwidth by default, and it can meet the bandwidth requirements of wireless simulation. In some scenario, the 40 bands is not recommended because it may be cause manual interference between the APs. Because if you do the bonding, maybe near the channel, they will have the influence with each other. And the next one, in order to avoid some old terminal do not support the channel from 36 to 64 channels. So we suggest to use these channels and another channel at the same time. So at least maybe one channel can be used for the terminals. This is a special for 5G. Okay, for 5G, because maybe some older terminals only can support two 2.4G but cannot support 5G. And in this scenario, we also have to deploy the 4G, 2.4G at the same time. And another one for the principle, how to do the optimization. If we choose the correct channel, but we still find some influence in our network. And the second one, we can do the judgment of, we can do some parameters to about the power local. And about the power local, pay attention. You have to know this parameters function. If we change the power local, this is used to control the transmit rate and control the range of the interference. Pay attention what means the transmit rate. The transmission rate means about the terminal. If you want to connect with the SSID, we have totally divided into several steps. The first one, you have to use some control message and then do the transmission with the AP, and this message we call it belong to the control message. And about the control message, later we can find the SSID name and then we will associate with the AP. And after we associate successfully, then we will send out some service manager. For example, you visit the YouTube, or maybe you open the Laker link and then join the training. This message we call belong to the service message. And the second step, if we change the power local, we will have the limit of the service transmission. We will limit the rate, what's the highest through output to visit the internet, what's the speed to visit the YouTube. So this belongs to the transmission rate. And also if you change the power local optimization, you can limit the range of the signal coverage. For example, about this AP, by default, if we make the power to become 100%, the range is this one. This is a coverage. If you reduce the power local smaller, maybe half, and then maybe only we can coverage half a area. So this is the function of the power local. So this is the key point of this training topic, the power local. And how to test which power local value is better for us. We can use the test like this one. We have to use a phone and then to use a tool like the fire moho and then to do the test. First, the AP power local is 100%. This means we will use the highest percent and we will test the result. The speed is 45 Mbps. And then you can reduce the power half to become 50%. And then the speed will still is 45. That means if you limit the power to become shorter, half of the percent, but the speed still is enough for us to visit the internet. And then you can have the power local again continue to be 25%. The speed is 45 Mbps. And if continue to become 10, you will find the speed to become smaller than the 25%. So that means we will suggest the setting to maintain good coverage and minimize interference. The power center is 20%. If someone say if I use 100% is also okay, but pay attention, maybe around your computer, you also have the other APs. Maybe all of the AP have the highest 100% power. They will have a big interference. So you have to use your AP, use a tool to get the smallest value of the power local. And in this value, we still can use the highest throughput rate, half and half. So about this feature, when the structure is very simple, we can find one AP and to measure the pressure power local value like the way we test one by one, half and half. And then to use a WISP platform to distribute the configuration to make the AP power to become, for example, like 25%. But if the architecture is complex, we suggest to be fine-tuned for each AP one by one. For example, in the studio scenario, maybe we need to deploy lots of APs, but if you directly to make all the AP power local value is smaller, maybe the coverage is not enough for us. And in the high density hole, store the AP under the seat. And in order to reduce the human body effective, because in the human body we have lots of water, and we have to turn before the start of the meeting, need to assign 15% of the external power local. Because maybe in your high density scenario, everyone have a seat now, and the power will be reduced a lot of. So in this scenario, we have to set aside 15% of the extra power local redundancy. So this is a suggestion. And another parameter is the coverage power. And pay attention, the coverage power is, if you change the coverage power, we will have an influence for the management, for the control message, special for the beacon and the probe. And about these two special frame we not discussed before, because this is exchange message between the station and the AP together. And the function is used to control the AP coverage range. For example, like here, if we have two AP and one the signal is very big, pay attention. By default, if your signal coverage is big, maybe your speed also is higher. But if you change the coverage power, you can make maybe your coverage power, your signal is smaller, but you still can use some higher speed, because we can use the power local to control the speed. So coverage power only has the influence to the signal area, to make the signal area bigger or smaller. But another one, how to control the speed, how to find a way to visit the internet, what's the speed you can use. We will use a power local to control. And of course, if you change the power local, you also will have the same influence for the signal area. So pay attention about this part. So if the signal is very big, for example, like this topology, and this is the range for AP1 and another range for the AP2, and you have the terminal station to connect with them. And about the first AP, we will find the signal is dash 62 dBm, but another one for the AP2 is dash 50 dBm. Of course, if we change the coverage power parameters on the AP, when we send out the beacon and probe message to the terminal, to the station, when station receive it, I can know in these places what's the signal strength of this AP. About the AP1 is dash 62. About AP2, the strength, the signal power is dash 50 dBm. So compare with the value, we know that the AP2 signal is better than AP1, right? And about the physical places, we also will find the station is connected with AP2 closer than the AP1. So we hope that the station can connect with the AP2, and we can get the higher speed and the closer connection with AP2. But about the station, how to do the roaming or not, choose which the AP we have to connect it. According to the parameters on the devices. For example, if the signal is lower than dash 75 dBm, I will choose another one. Otherwise, I think AP1 also can provide the function, provide the service for me. So in this scenario, maybe it's this one we call is roaming stackness. We still connect with the AP1, but actually AP1 is not the best choice for the AP, for the terminal. So in this scenario, we want to use a coverage power to change the limitation, to change the signal average For example, to make AP1, the signal is smaller, like -75 dBm. So in this scenario, maybe your station will directly choose AP2 as the forwarding out AP. Okay, so this is the function. And the first one, if we have only one power, this station will connect with the AP, only one AP. And then we can change the coverage power and limit the range. And the better, this is the first one, recognize AP coverage from the location. And we can change the value to make sure the edge signal strength to become -65 dBm. And then if we deploy two AP, and we have the terminal, after we go around and in the middle of these devices, then the AP1, the signal strength is -65 dBm, and the AP2, the signal also is -5 dBm. So in this scenario, the station will do the seamless roaming between APs. After I go right a little, I will try to directly connect with the AP2 because they have the same strength. Okay, so this is the function of the coverage power. So pay attention about these two parameters. If you change the power local, you will reduce the speed, and also you will reduce the signal average, signal area. So lots of scenario we will change the local power. But some special scenario, for example, maybe between these two devices, two APs, and the signal we want to change to become same, and then the station can do the seamless roaming successfully. In this scenario, maybe we will change the coverage power to use the special value of the edge signal strength to become like this example, -65 dBm. So in this scenario, we can smoothly roaming between two APs and also can avoid the remote association and roaming vesicles. So this is the function. And of course, in your real network, when you change the signal, you still have a little overlap between two APs. Like this topology, this picture, if there is empty places, the station will lost connection with APs. So this is not the last result. By the result, these two APs, at least we have a little overlap of signal areas to coverage this message. Okay. And another one for the coverage power optimization, we have to make more dual band active terminal access to 5 gigabit. We have to set 2.4 gigabit channel coverage power configure is 8 dB and smaller than 5G. That means if in our network we use 2.4G, 4G and 5G at the same time, because 5G we can have lots of non-overlap channels. So, and also we can provide higher speed by some special technology. So in this scenario, we hope that the terminal can connect with 5G and has higher priority than the 2.4G. So in this scenario, we can make the coverage power is 8 dB smaller than 5G. So in this scenario, maybe we will find that 5G signal will be stronger than the 2.4G. Okay. And pay attention about this one. Coverage radius of 5G will approximately half compared with 2.4G. Because due to the airspace loss in the high substrate transmission. Because about the 5G, we have the higher frequency. So about the lambda, the wavelength is shorter than the 2.4G. So this is the coverage power. Like this one, 2.4G signal, the value is -68 dBm, but about 5.8G, the signal is -65 dBm. So if the terminal search the SSID from 2 bands, we will choose the 5.8G at first because this strength is stronger. And the process and the step is in the simple architecture layout, we can find two APs and calculate the coverage area control value, and then use the width to distribute the configuration to APs in bench configuration. All the AP, maybe we can use the same coverage power. And in the complex architecture, we recommend to use special value like the 15 dBm in 5G, 7 dBm in 2.4G. This is the recommended value. And then we can use a width to distribute the configuration of all the devices. And later, you still have to adjust the AP by one manually because maybe different places we have different oscars. We will have some scenario, some places we will have the wall, some places we will have the door. So in the complex architecture, you maybe finally still have to use your phone to test the result, and maybe manually to reduce or maybe make bigger of the power value. And for a wireless network scenario, we have to some frequent roaming scenarios. We suggest when you do the roaming test, if your packets drop or maybe lost, the count number is over 5, then you can reduce the coverage area control setting and then to overcoming the staking client issue. That means when you do the test of the roaming, maybe the signal of the AP1 still is too strong. So about the physical places, AP2 is better, but you still to connect with AP1, but now the speed is not enough for us to wait the resources. So in this scenario, we hope you can reduce the coverage value and then you can direct it to connect the AP2 and then to wait the resources. And another one for the high density scenario, relevant adjustment of the coverage control will help to address the requirement. This is the note. It is necessary to conduct through station roaming tests to find out the best balance value for these parameters. So, although the first one you have to make the connection and use your phone to test that the signal is better to connect with the other AP when we own work. And the second one you also have to test the drop account. And later when you do the coverage, maybe someone says the signal is too weak for us, too poor for us, but still we don't change the roaming and the packet is lost. In this scenario, we also have to change the parameter of the coverage area control. And another one, recommended to 5G radio share not lower than 10 dBm, whereas the 2.4 gigabit radio lowest value should be 1 dBm. So this is the principle that we hope we can connect with 5G has higher priorities than 2.4G. Okay, so this is the suggestion and the note. In certain scenario, we can shut down on 2.4G, maybe feasible of the fill-in high density requirement because maybe some terminals are not support the 5G. And when 5G and 2.4G radio coverages power value are disabled to each other, that means the SID less than the 3 dBm different. The station may probably attach to 2.4G radio instead of 5G. So this is a note when we deploy the two band at the same time. And for adjust two APs operate in 5 separate streams. AP working in 1.5.1G, especially because we have two channels we can use on the 5G. One is 5.1G, and the channel range from 36 to 64, and the coverage value suggested to use 3 to 4 dBm. lower than the other AP operation at 5.8G, the band from 149 to 161. The coverage control setting, we suggest 5.1G is lower than 5.8G. That is what to ensure the air connection for stations connected to either APs. So this is a function. And another one for the coverage power, it was necessary to reserve 3 dBm of the value in the allowance for the APs used on high density deployment, especially in stadia scenario, because maybe in the scenario the AP will be installed under the sea, and then we will send the radio power. We will find the radio power is less than the normal we test on some places because of the human body when we have the seat. So this one is very important. By default, maybe we have to reserve 3 dBm for the special scenario of the stadium, because maybe we will have lots of people and have a seat here. Also have influence of the signal area. This is a second one. And about these 3 parameters, the first one of the channel, lots of scenario we will choose. And you also can directly use a platform to click and choose a best channel. And the second one is a power local. These parameters is usually used in our network. And we can change the power and then immediately to have influence of the signal area and also have the influence of the speed. And the third one, if you special places, you want to reduce the coverage, but you don't want to reduce the speed. You only want to reduce the signal coverage. You can change the you can change the parameters of the control power. So this is 3 principles. And the next principle, we also have to consider about the interference avoidance. The interference source are divided into 2 types, one for the WLAN interference source and another one for non-WLAN interference source. For the WLAN interference source, it's very easy. All the devices use the same protocol of AO2.11. Like now I deploy the AP1, and some places maybe we also use Ruijie devices use AP2, deploy AP2, but they use different channel or maybe use the same channel, and then we will have an influence. And another one, maybe in the same places, we also will deploy the other vendor devices of the AP. They also will have the influence. These devices we call is WLAN interference source because we use the same protocol. And another one we call is non-WLAN interference. These devices, we don't use the double wireless protocol like AO2.11, and this equipment also don't follow the mechanism of the device's communication, SISMA-CA. SISMA-CA is a mechanism between the AP and the station, how to find the devices and how to avoid the influence. This is a mechanism. This is a detection mechanism. And as long as in the working status, these devices, like the microwave, like the other devices, we will provide a very strong influence for the network. That's why in our deployment, we say if you deploy the AP in your network, please avoid these devices or maybe far away with these devices. And these devices were working in 2.4G. One solution maybe is in your AP, you don't use 2.4G. Otherwise, they will have a big influence with each other. This is the main principle we have to know when we do the optimization. And another one, we also have the other optimized methods. And we only know this principle is enough. The first one is user isolation. For example, maybe in the public Wi-Fi scenario, you deploy the Wi-Fi wireless network maybe for the government. and maybe in some public places. And all the terminals no need to communicate with each other. All the stations, we only have to wait the public resources is enough. We don't need to do the communication with each other. So in this scenario, we hope that we suggest we can enable the user isolation. And then all the terminal's message, includes the broadcast message, will never forward to the other station. And the command is like this. On the AC devices, in the WIDS, then you enable the user isolation on AC and AP together. And then the configuration will be done to the AP, and all the stations only can wait the resources we call is north and east resources. North and south resources. We only can wait, for example, the internet metric. And between the stations metric we will directly to discuss also includes a broadcast message. So this is a function. And of course, maybe in some web page, you only to click to choose the user isolation is enough. And another method like the wired network broadcast isolation. Before we begin to optimize the wireless network, actually about the optimization we can divide it into three parts. One is the wired network, because all the wireless message will be forwarded out to pass through the wired network. So in the wired network, we also can do some optimization, for example, to reduce the broadcast domain as much as possible. So we have some technology like the WLAN, like the port protection, like some RLDP, like some STP principle, something like this. And the second part is the wireless part. Between the AP communicates with the station, and we also can do some optimization. And also in the AP, we can change some parameters to reduce the signal strength, and then to reduce some special connection with the AP. This built to the wireless part. And the third part, you also can do some parameters on the terminal. For example, you can change the roaming, and in some fixed places, you can make the roaming possible to become smaller, because maybe these devices will not go around. But in some public devices, lots of people will go around and connect with each other. And in this scenario, maybe your terminal also want to do the roaming as much as possible, as soon as possible. So we can divide the optimization in three parts. And this picture shows the methods how to do the optimization for the wired network. We can add the WLAN, we can add the port protection, and also we can use the RLDP technology. And pay attention, the wireless network required to support layer 3 roaming, but the switch port protection on the PoE shell will be turned off to prevent roaming failure. So if you want to use layer 3 roaming in your network, you cannot enable the port protection. So this is a limitation. And another one for the optimization, this one also usually will be used in our network. Per user rate limit. We can enable the user speed limitation for different bandwidth requirements. For example, we can divide a different terminal and have different rate, have different priority. And to avoid one terminal take lots of resources to wait the internet, but the rest of the others cannot wait. So in this scenario, we can use a per user rate. And the command is on the configuration of WLAN config 1, and the name is Ruijie. And the WLAN based per user limitation, the upstream, the average rate is 300. The burst data rate is 350. And the downstream speed, we also can have the limit. And pay attention, by default, the rate limit value, if you enable, is 8 kbps. And recommended the burst rate set to be 1 to 1.2 or to the 1.5 time from the average date value. So this is a suggestion. Of course, if you don't assign these parameters, maybe one terminal will take lots of resources to wait the internet, and then the second one have to wait, or maybe the speed is very slow. This one also lots of time lots of scenario we will choose to change the parameter. And another one for the egress bandwidth and the contact calling upgrade. This is the method. For example, you do all the parameters, but you still found that the egress bandwidth is not enough. It's overutilized. So in this scenario, maybe this is a problem that your egress devices, the calling is not enough. So we can add a special calling service like the Ruijie Power Catch to address this issue. Like the case study on the airport. The airport internet gateway will never fully utilized before any wireless optimization, and upon the RF optimized for the Wi-Fi network, internet bandwidth was constantly used over 95%. So the Wi-Fi station will enjoy smoothly internet surfing experience after we add the power catch implement. So this also maybe is the reason because the egress devices, the calling message is not enough. The coaching resources is not enough. So you can deploy it. And another one, maybe you can provide the adjustment for low wireless rate. For example, in the internet, we have lots of protocols we can use, right? Like the AL2, the 11A, B, and G. And this one we can deploy in different band, 2.4G or maybe 5G. And we can disable this lower rate and to avoid low rate pull down the air interface performance, because maybe about these protocols we will send some control message to the air interface, and then your air interface have lots of ability to deal with this message. Then the speed also will have the influence. So we can use the command on the AC controller and disable all the speed. And pay attention, area with poor Wi-Fi coverage and or suffering from the channel interference, it is not recommended to disable the lowest speed rate supported. So if maybe some terminal or maybe special stations only can support these protocols, if you disable it, maybe they cannot connect to the internet. So this is the method. And another one, we also can disable the RIM setting, because we maybe will deploy the DCA and the TPC function of the RIM in order to take up a lot of CPU and memory resources. So if you frequently for the DCA and TCP will cause the wireless network is not stable. So maybe we suggest to disable these two functions. This is a command. How to disable these protocols on the AL2.11b and AL2.11a protocols. Of course, by default, these two functions are disabled. And we also suggest to use ways to optimize the channel and power automatically. And another one for the beacon period interval adjustment. And the beacon frame is special one because we will use this frame to do the communication with the AP, and then we can connect with the devices and to search the SSID and connect it and associate one AP. And by default, we will send out the beacon frame 100 ms, so the time is very small. So you will find that all the time, every 100 ms, we will send out one beacon frame in order to let all the terminals can connect with the AP successfully. So in this scenario, maybe the places your AP, you only have less user will connect with the AP. You can set the time longer. For example, to address the time to become 150 ms or maybe 300 ms. So in this scenario, within the certain time, we will send out we need less resources to send out the beacon frame. And the command is here. You can add the AP configuration and to change the beacon period to become 20 on radio 1. And pay attention. If here you make the beacon time longer, we will make the terminal to become the installable connectivity because I have to wait in the passive way. We have to wait beacon frame and then to connect. If you make the time longer, I have to wait a long time, right? And recommended the SSID broadcast count per AP if less than 4 to attend the good station experience, connective experience. So this is a recommendation of the value. And another one for the CPP TCP AT optimization. This one is special used in the web authentication. In your network, if you have deployed the web authentication, after the station connects with the AP and gets the resources, we also have to establish the web connection. And the web uses the TCP connection and the value is 80. So if we use this value and to make the time longer, you need to wait. Someone maybe say lots of people log in our web authentication, and I have to wait a long time, and then I can open the web page and then to finish the authentication. So in this scenario, maybe you can change the second time. For example, use a command CPU protect type TCP8 and PPS 3000. This is a function. And another one for the optimization is centralized transmit, the ARP guard. Because in the special mode of the centralized transmission, all the message from the station we have to transfer to AC and let the AC to help us to finish the message forwarding to the destination. So in this scenario, if we have lots of terminal and every terminal, when we wait the message to different resources, we have to the ARP translation at first. So all the message will be sent out to the AC and the AC give us a reply. But especially who needs the ARP protocol, who needs the ARP resources, this is a gateway. Because some scenario, the station gateway is a call switch or maybe access switch, not about the AC. So we hope that the ARP guard of the station, we can make some other devices to do this function. In this scenario, you can use this command, ARP guard optimization in the NFPP protocols, and you can add the ARP guard trust host, what's the IP address, what's the MAC address. This is a function of the ARP guard. And after that, we will add the gateway ARP items to the ARP guard trust table. And in this scenario, no need to forward this message to the AC devices. And another one for the data plan wireless broadcast. And this method is used to forward all the broadcast message to their air interface. Okay, so this is a function. And if we forward the broadcast to the air interface, it will occupy much wireless resources. This is the difference of the wireless and the wired network. About the wired network, if we set the speed is 1 gigabit, and finally we can use 1 gigabit bandwidth to forward out the message. But about the wireless, it's different. Maybe the physical interface is 1G, but we need lots of resources to follow some control plan to detect there is a conflict or not. So in this scenario, we hope that some broadcast message maybe only can be forwarded to the air interface, or maybe no need to forward to the air interface, and this air interface can forward some normal message successfully. And in this scenario, we can disable the function of the broadcast or wireless broadcast. And by default, this value is disabled. The configuration is data plan wireless broadcast disabled. And in some special scenario, we hope to enable this function, but by default, this is disabled and we no need to enable it. Best beacon interval for AP. Actually, this one no know the real or maybe a certain value. Depends on the real devices, on the real scenario. If you have lots of people, lots of terminals, and then you send the beacon time is too longer, they need more time to connect with devices. But if you make the time too shorter, for example, in the studio places, if you have a meeting or some other activities, we can make the time shorter to let lots of people to connect with us. But after the meeting, maybe you can make the time to be orange, like the 100 ms, or maybe to make to become longer. There is no certain value say which one is better, which one is not better, but it depends on your real scenario. And the suggestion is by default we use a 100 ms is enough for us. Okay. So also some other time, like last week, we also discussed some hello message for, yes, for by default this is 100 ms. Like the other time we talk about in the OSPF, we say OSPF message will send out the hello packets to maintain the relationship. The default time is 10 seconds. Is 10 seconds. And we don't say the 10 seconds longer is better or maybe shorter is better. Also depends on your real network. If your network is stable, the network topology is impossible to change a long time. You can make the hello time to become longer, like 1 minute or something like this. Otherwise, maybe you're up down all the time, or lots of time, maybe the network is unstable. You maybe have to shorten the hello time to make the devices to get the correct routing information. So about the time, there every time there are no certain value, maybe say shorter is better or longer is better, depends on your real device, real scenario. And another one, the methods we can send out the response RSSI and associate RSSI. And pay attention about this part because we skip the relationship between the AP and the station. How about the station connect with AP? So this part maybe some frames are a little unfamiliar for us. About the station, how to let the AP help us for the traffic. We also have a lot of message exchange between AP and station. One is a response, one is a social. Response and the beacon is used to connect with the SSID to let AP know I am the station and now I want to connect with you and then please let you to help me for the traffic. So the first process is response. And the response value is finally to determine that you can connect with this SSID or not. And then is associate. The associate will be finally to detect you can associate with me or not. If you are not associated with me, I will direct to discuss the message from you. So we also can change the response ISSI and associate ISSI. For example, here about this client information, we found the first client, the ISSI value is 70. And if you set the ISSI value response value, the value to become 20. Finally, your station cannot search the message, cannot search the SSID, and also cannot connect it. This is a response. So associate means when the user ISSID is smaller than this value, the AP will kick the user out. For example, we set the associate ISSID to become 20, and finally we found the ISSID value to become 70. Maybe the station is working, right? And then I would directly delete the client out of my list. Then your client maybe try to connect with another new AP. So in this scenario, we can take more resources for the terminals, and this terminal can have the stronger signal to connect with me. So this one also is a value. But pay attention, if we change the value to become very big, lots of the stations maybe cannot connect with your network. So pay attention about this part. We can use the command show.11AA and to check the result. And here is some suggestion command. If we configure the response ISS value to become very large, it will cause some user cannot access the internet. So we suggest the value is 20. If we configure the associate ISS value to become very large, for example, the user walks slow on the road and the strength become lower suddenly, then the AP will directly to delete it. To achieve the perfect access and roaming, we suggest to modify the coverage area control. When we change the coverage area control power value, all of the parameters includes the ISS, includes the response ISS and the associate ISS. Both of them will have the influence. So that's why we say in our network, except the per user speed limitation and some user isolation, some of the other value we suggest to directly change the power local or maybe the coverage area control, because when we change these two parameters, all the other methods will be changed at the same time. So this is better to change to do the optimization based on the device's whole, not about one parameter. And another one for the band selection. We suggest maybe in our network, let's if we have 5G and 2.4G at the same time, and we hope lots of the user can connect to 5G at first, so we can make the signal of 5G about the power is bigger than 2.4G. But if we enable this function, enable the 5G priority function, it will cause single frequency terminals which only support 2.4G, associated with slow speed, because not all of the terminals can support 5G. Although even now real network, not all the terminals can support the 5G. So in this scenario, we hope that the 2.4G and 5G can be used on the same time. We have to enable these two bands at the same time, but the 5G has a stronger signal than the 2.4G. In this scenario, if the terminals can support two bands, we will connect 5G at first. If one terminal only can support 2.4G, we still can have one band to support it. Okay. And we suggest to adjust the beacon power by modifying the coverage area control value to ensure the signal strength of 5G receive a little bit stronger than 2.4G. Then the station can connect to 5G smoothly, not directly enable the 5G priority function. Maybe they have the same result, but the principle is different. Okay, that's all about the WLAN optimization. And about this optimization, we talk lots of parameters of the network and how to change the parameter and to make the experience better. And the key point we say is the first one, you can use the uh, channel, right? About 2.4G and 5G, which channel we can use. We can manually choose or maybe use some platform to choose it. And also maybe some Ruijie cloud can do the function. And another one we usually do to change the power local or maybe to change the coverage power area, coverage control area to change the signal and change the speed. And some special list, maybe you can limit the per user speed, like the upstream, like the downstream speed. And also some terminals no need to communicate with each other. We can enable the user isolation, something function like this. And the other function we suggest, we only know we have these parameters to do is enough. Okay, that's part about the optimization. And if you have any questions, please write down on the chat window. And 15 minutes later, and we will continue next part to talk about the redundancy and also for the for the site survey function. Two parts. 50 minutes later, maybe come back on 35. We will continue next part. Someone say Wiz is free application. Actually not. Ruijie Cloud is free, but the Wiz is not free. And the detail of the fee, maybe you can contact with the Ruijie sales team.